All right, so when we're using the quadratic formula, that portion of the quadratic formula, or that expression that is underneath the radical, underneath that square root, is what we call the discriminant. So here in the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So b squared minus 4ac, that's our discriminant. Now, the discriminant, if we know what it is, it can tell us a few things about the equation. And it says if the discriminant is positive, so we get a positive number when we do b squared minus 4ac, that's going to tell us that the equation has two solutions or two x-intercepts. And one thing we could add in here, especially as you get older into Algebra 2, it's going to tell us that those are real solutions. Because every equation, every quadratic equation is going to have two solutions if the discriminant doesn't equal 0. So we've got two real solutions if it's positive. If the discriminant equals 0, then we only have one solution or one x-intercept, which the way you end up with that is if our vertex is our solution, because that would be the only point crossing the x-axis or hitting the x-axis if we have a discriminant of 0. And then if the discriminant's negative, the equation has no real solutions, or we could say it has two imaginary solutions. And imaginary solutions is actually something we do deal with in mathematics. Beyond this point, though, we're not going to cover it right now. But if it's a negative discriminant, that means we have a parabola that never crosses the x-axis. So we don't, it's either above, all of it's either above the line or below the line representing the x-axis. All right, so here we want to find the value of the discriminant and then use it to determine how many real solutions it has. So remember the discriminant, b squared minus 4ac. So we're going to look at our a, b, and c. So a is 1, nothing in front of that x, so we assume it's 1. B is negative 2, c is 4. Plug it into the discriminant. Negative 2 squared for our b squared, minus 4 times a, which is 1, times c, which is 4. So negative 2 squared is 4, minus 4 times 4, or 4 times 1 is 4. 4 times 4 is 16, which is negative 12. So it's a negative, so that's going to be no real solutions. If the question said how many of what kind, then you could say no real solutions, but it would have two imaginary solutions. All right, so the next one, identify our a is negative 3, b is the 5, and c is negative 1. So b squared is 5 squared, minus 4 times a, which is negative 3, times c, which is negative 1. So that's going to be 25. Negative 4 times negative 3 is 12. 12 times negative 1 is negative 12. 25 minus 12, 13. So that's a positive discriminant. So a positive discriminant is two real solutions. And the last one here A is -1, B is -10, and C is -25. So plug it in. B squared, so -10 squared, minus 4 times A, which is -1, times C, which is 25. Or should be -25, sorry. Left that off. So -10 squared is going to be 100. -4 times -1 is 4. 4 times -25 is going to be -100, which is going to be 0. So it's going to have one real solution. All right. So that's one possible usage of the discriminant. The other possibility is very similar, right? Where you can use the related equation to find the number of x-intercepts of the graph of the function. So using that discriminant, since a solution of a quadratic is the same thing as an x-intercept of the graph of the function, if we figure out how many real solutions we have, then that's going to tell us how many x-intercepts we have. So same basic process, we're just switching the word solution with x-intercept. So y equals x squared plus 6x plus 3. So we're only looking at the right side here. Don't worry about the y equals. Looking at this part just like it was a quadratic expression. And so we're going to look at it as 0 there. So our A is 1, B is 6, C is 3. So using our discriminant, B squared minus 4AC, 6 squared minus 4 times 1 times 3. 6 squared is 36. -4 times 1 is -4 times 3, -12. It's going to give us 24. Once again, that's a positive, right? Positive 24. So we're going to have 2 x-intercepts, right? Because that discriminant would tell us that we've got 2 solutions, which in turn is the same thing as 2 x-intercepts. All right, next one. A is going to be 1, B is 6, and C is 10. So B squared is going to be 6 squared minus 4 times A, which is 1, times 10. It's going to give us 36 minus 40. Which is going to give us -4. And so in this case, we've got a negative. And anytime we have a negative, that means that we would have no real solutions, or in this case, no x-intercepts. Or 0 x-intercepts. And the last one here, our A is 1, B is 6, C is 9. So basically in these 3 equations, the only thing that's changing is that C term. So still B squared, 6 squared, minus 4 times 1 times 9. So it'll be 36. -4 times 1 is -4 times 9, -36. So 36 minus 36 equals 0. And so 0 tells us we have one solution, or in this case, 1 we have 1 x-intercept. All right, so that is section 9.6, or that is the discriminant.